All right, going to look at the double angle formulas. Sine 2 theta. So the way we're going to create these is by using the identities we saw yesterday. Instead of saying 2 theta, I'm going to call it theta plus theta. Sine, you will remember, goes sine, cos, cos, sine. If it's a sine, it's a sine. But you'll notice they're both sine theta, cos theta. So we get an answer of 2 sine theta, cos theta. So the sine of 2 theta, 2 sine theta, cos theta. All right, let's have a look at cosine. So we'll do it the same way. Cos, cos, sine, sine. If it's not the sine, it's not the sine. We get cos squared minus sine squared. That's one way we could write this identity. Another way we could write it, if I wanted the ratios to be all the same, I could change the sine squared to be 1 minus cos squared, and I get 2 cos squared theta minus 1. Or, another way I could write it, if I wanted them all to be sine squareds, I could change the cos squared to 1 minus sine squared, and we end up with 1 minus 2 sine squared theta. So we actually have 3 different ways we could rewrite the cosine of 2 theta. I guess it just depends on the question as to which one we end up using. Okay, let's look at tan. Tan plus tan on 1 minus tan, tan becomes 2 tan theta on 1 minus tan squared theta. Okay, so we call them double angles because it doesn't have to be 1 theta and 2 theta. I mean, it could be the sine of 6x is equal to 2 sine 3x cos 3x. So we call them the double angles. That's when we say double. Cos 2 theta, we have 2 cos squared theta minus 1. Just note this. I could rearrange that and make cos squared the subject. And we get cos squared is a half of 1 plus cos 2 theta. The sine squared one, I could rewrite to make sine squared the subject. And I get a half of 1 minus cos 2 theta. Those two relationships are going to become really important when it comes to integrating trig functions next year. And in fact, next year I'll probably say, hey, remember last year when I said those things are going to become really important? And I'll go, remember what they are? And you'll go, no. Right? And then I'll remind you. But trust me, they will become very important. We get a question like this. Cos theta is equal to 2 theta, 2 thirds. Find tan 2 theta. Well, I'm just going to draw up a triangle. That gives me all the ratios that I need. Tan 2 theta was 2 tan theta on 1 minus tan squared. So subbing in my tan theta. Ooh, tidy that up. Eventually, there it is, minus 4 root 5. We're going to find the exact value of sine 5 pi on 12 cos 5 pi on 12. Okay. Now, you might look at that and think, okay, how can I create 5 pi on 12 out of 2 angles that I currently know? But actually you can do this a different way, because you've got that pattern sine cos, which is in the sine double angle result. So we've got sine 5 pi on 12 cos 5 pi on 12. Well, that's going to be a half of 2 sine 5 pi on 12 cos 5 pi on 12. Well, 2 sine cos, that's the double angle result. So double 5 pi on 12 is 10 pi on 12. Or 5 pi on 6, which is one of our exact values. Sine 5 pi on 6, we are in the second quadrant. Sine is positive. It would be the same as pi on 6. Pi on 6 is 30 degrees. Sine of 30 is half times a half. A quarter we get as our final result. Cos theta is 2 thirds. Find the exact value of sine theta on 2. So again, theta is double theta on 2. So it seems to suggest I can use the double angle results. So I'm going to use that sine squared one where I rearranged it. And I can say sine squared theta is a half of 1 minus cos double the angle. But I'm going to rewrite that formula to be sine squared theta on 2. So long as it's double, it'll work. So sine squared theta on 2 will be a half 1 minus cos theta. They've told me cos theta. Okay, so sine squared is 1/6. Plus or minus 1 on root 6. Can I narrow it down, I guess, is the question, to either plus or minus? And maybe that red underline is a giveaway that no, I can't narrow it down. If cos theta is 2/3, cos theta might be in the first quadrant. Might be in the first quadrant. In that case, half theta would be acute and it would be positive. But cos theta could be in the fourth quadrant. Now if you halve something in the fourth quadrant, you're going to end up in the second quadrant maybe the third quadrant. Either way, cos is negative. So I can't narrow it down. So yep, plus or minus. There's no way I can work out which without more information. Alright, let's do a trig proof, an identity proof. Square root of 1 minus cos 2x on 1 plus. So I'll start with the left hand side. Now I've got 3 different things I can substitute in for the double angle of cos. I want to end up with tan x. Tan can be rewritten as, right, so ideally if it can be written as sine on cos, it would be smart for the top one to use the one that ends up with the sine ratio, and for the bottom one use the one that ends up with the cosine ratio. So on the top I'll use 1 minus 2 sine squared x, but on the bottom I'll use 2 cos squared x minus 1. Tidying that up, and we get something quite nice. 2 sine squared on 2 cos squareds. The 2's cancel, like this little HSC question, because people made a big mistake. They saw the sine 3 theta and the cos 3 theta and thought, okay, I've got to come up with a result for sine 3 theta. And they did that by going, oh well, 3 theta would be 2 theta plus theta, and then go sine, cos, cos, sine, and all of that. And then did the same for cos as well. Now eventually it worked out, but gee, they wasted a lot of time. Because if you actually just get the left hand side, treat it as an algebraic fraction, where the common denominator becomes sine theta cos theta, look what happens on the top. Sine cos minus cos sine. Sine cos cos sine. That would be, yeah, sine 3 theta minus theta. Now, you'll notice what I've also done though, is multiply top and bottom by 2, so on the bottom I now have 2 sine theta cos theta, which is, so we get sine 2 theta on sine 2 theta, which cancels, and gives me 2. How did I multiply by 2? I didn't just multiply by 2, I multiplied top and bottom by 2, which is equivalent to multiplying by 1. 1994, whoa, that's a long time ago now. 2 tan on 1 plus tan squared. Remember the double angle result was 2 tan on 1 minus tan squared. So right, how do we turn this into sine 2a? Alright, let's have a look at the left hand side. What have I got? 2 tan a on 1 plus tan squared. It's none of those. I could turn 1 plus tan squared into sec squared. That's a possibility. Or I could just turn everything into sine on coses. Which way did I go? I went sine on coses. Alright, well, fraction on fraction. I'll multiply everything by cos squared. So on the top I get 2 sine cos, and on the bottom, look what happens. Cos squared plus sine squared. Cos squared plus sine squared. 2 sine cos. And so there it is, straight away. Sine 2a on 1, sine 2a.